In induction heating power supplies, how does the automatic resonant frequency tracking technology determine the resonant operating state? To achieve an excellent induction heating power supply, the power supply must incorporate automatic resonant frequency tracking technology that adapts to load variations, ensuring it operates under optimal conditions. By understanding the phase difference between the inverter voltage and the inverter current, it is possible to determine whether the power supply is operating in the correct resonant state. How can the specific phase be judged through waveforms? Below, we will provide a detailed introduction. Prepare an oscilloscope, a differential voltage probe, and a high-frequency current probe. When testing the power supply, it is advisable to perform isolation and safety procedures before using the oscilloscope. Then, clamp the differential voltage probe across the two output terminals of the IGBT, and place the magnetic ring of the high-frequency current probe around one of the IGBT output wires. Now, we will demonstrate using the ST310 series resonant induction heating power supply. This is a main control board with 16-bit ADC high-speed sampling control, featuring strong anti-interference capabilities. When the power supply output is started, the following can be observed on the oscilloscope. The yellow waveform represents the inverter current, while the blue waveform represents the inverter voltage. It is worth noting that, during the operation of a series resonant power supply, the inverter voltage is a square wave, and the inverter current waveform is a sine wave. To determine whether the inverter voltage leads or lags the inverter current, a detailed analysis can be performed using the waveforms. One cycle of the output waveform corresponds to 360 degrees, with half a cycle corresponding to 180 degrees. At the midpoint of the half cycle, the waveform is at the 90-degree position. The actual phase calculation is based on the phase difference between the zero crossing point at the rising edge of the inverter voltage waveform and the zero crossing point at the rising edge of the inverter current waveform. The waveform above shows that the inverter voltage leads the inverter current, indicating an inductive state. After capturing the measurement waveform, you can expand the waveform on the oscilloscope to quickly estimate the approximate phase difference between the inverter voltage and the inverter current. Now, let's examine the waveform on the oscilloscope together. The phase on the waveform is approximately 30 degrees, while the phase displayed on the main control board's test mode interface reads 31 degrees. Series resonant power supplies operate in a weakly inductive state, while parallel resonant power supplies operate in a weakly capacitive state. If the induction heating power supply is connected to an isolation transformer at the output, during actual measurements, the probes can also be connected to the secondary side and output terminals of the isolation transformer. This method is more convenient for testing, although the inverter voltage waveform may become slightly distorted due to the isolation transformer, but this does not affect the phase measurement.